All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna be doing a bit of a short stream because I started the stream really fucking late. That's on me. Oh, just a minute. We should not be doing that. Yeah. Okay. Yeah. Yeah, I started the stream really late. I'm gonna try and go for at least 45 minutes. I didn't want to miss today's stream. So I tried my best and like I had to restart my system and I lost a good like hour to that because um, I had my usual tech issues with my machine and I had to restart the machine I think two, maybe three times in order to get it in a somewhat stable condition. And even that is kind of like iffy right now. So I was like, okay, let's just do what we can. We are probably not going to be doing any coding specifically, but we're going to read up on more ESP32 Rust stuff. Another reason why I was late to the stream was because I got busy trying to solve a problem because I finally set up the entire ESP Rust tool chain, all the stuff that's required, the targets and the compiler and whatever other extra stuff was needed. I set it up, and I even had the ESP32 connected. Just a second. Yeah, and then um, when I finally tried to compile the compile and run the program, then it kept saying that it couldn't connect to the device, and so then I did some sorry, so then I did some research and I found out that apparently it's something to do with permissions because you have to tell the kernel explicitly that hey, you need to allow this device to or devices that contain this product ID and this vendor ID and stuff like that. You need to allow them to be controlled by whatever other user groups. In my case, I needed to just allow all user groups for the sake of simplicity. And so I was just trying to set that whole thing up. Fortunately, Gemini made that whole process a lot easier. I just had to have a conversation with Gemini about it. And there were two ways that we could go about it. One was using the concept of groups in Ubuntu, and the other is by editing some rules um, that are followed by I forgot what it's called, something called udev. Basically you can define a custom set of rules for specific like device um, product IDs, specific devices with certain product IDs and vendor IDs, and you can give like specifications for what permissions they're gonna have. So I just needed to set that up for all possible ESP32 related devices. And again, all thanks to Gemini, all of that process was easy. I didn't have to go digging for information. Gemini presented me with these two options and I picked one of them. After doing some research, after having a bit of a conversation about, hey, what's the difference between these two methods, um, I found out that or I we came to the conclusion that using this method where we create that set of rules and just update the udev manager thing that's running, that would be a much easier process than the other suggested method, which was to add my current user account to one of the groups that is allowed to make device changes, because that method, um, as simple as that method would have been, at least according to Gemini, it would have required me to either log out or reboot the computer. And I cannot reboot this computer because I have stuff running on here. This computer is hosting like multiple tmux sessions. I can't just reboot the machine. That's just not an option. So I went with the other option, and the other option didn't require a reboot, which was great. So yeah, after I got done doing that, now the board is being recognized. And give me a second. I've been trying to open up an Ubuntu instance on my machine. But yeah, we're just gonna be doing a bit of reading. So I'm done installing the toolchain. I'm now able to generate a project using ESP generate, and then I'm able to use cargo run to just compile and run that. And basically, cargo run in this case is being programmed to um, what was I saying? Yeah, in this case, cargo run is going to be compiling the code for a specific target, which in this case is the Extensa CPU. And then that compiled binary is going to be flashed onto the ESP32 using ESP flash. And then it's going to run. So all of this is happening through cargo run. I don't have to do these multiple steps myself. I just need to do cargo run, and all of the other instructions have been handled by a bunch of like config files, a bunch of like toml files and stuff. Sorry, got distracted. So now that I'm done with that, I think I'm ready to just get started with no STD programming. And there's a couple of different ways to go about this. So that um, the first thing that I looked into is this Hello World program. There is an entire repository where all of these code examples are listed. Is there a link that I can click? Generating. Okay, okay. Understanding ESP generate. Um, Workshop. Yes. Workshop is probably gonna have the link to. Yeah, here it is. So this is what I'm going to be using now, because of course I'm using. Oh God. Okay, it signed me out from GitHub as well. Okay, great. I can deal with that later. That's fine. So there are a couple of examples here, a couple of very simple examples. Once we get to the point where we know how to do very basic stuff like LED blinking and pressing a button, and there's a basic hello world example, which is great because this in this case the hello world example, it prints hello world to the console, to the terminal on your computer, the computer that the ESP32 is connected to. So this way you do still have some way to print stuff to a terminal. You're just not printing it to the ESP words. You're just not printing it to the ESP32. Why was that so hard? Yeah, you're just not printing it to the ESP32. You're printing it to the terminal on your computer. So once I've gotten a hang of basically what I'm trying to learn is the very basics of oh, just a second. Yeah, okay. Basically what I'm trying to learn is the very basics of setting up an ESP32 Rust project, and then um, writing some very basic code for it, because I noticed that when a project gets generated, there are two oh, accidentally hit the stand. Okay, there are two things that get generated. You have a library and a binary. So like there's two options there. There's a binary folder, a bin folder, within which there's a main.rs, but uh, in the root of, or well, in the source directory, there's, I can show it to you. Why am I describing it? Also, they said read the book. So let me open that up and see which book it's pointing to. We suggest you start by reading the book. Is this a different thing? Um, okay. Check the hardware. Oh, okay. So any problems that I would have run into, I think the solutions would have been here. Um, a USB device. Yeah, I didn't think about looking at this, which I mean, to be fair, I I found another way of doing it. I still managed to solve the problem, so I think we are good. Uh, it says connect the Espressif Rust board to your computer, verify a tiny red control LED lights up. The device should also expose its UART serial port over USB. On Linux, a USB device under LSUSB. Okay, yep. What did I just press? Yeah. In my case, it says Kinhang something something. It also doesn't have this vendor ID and product ID. It has a different one, but I've added the correct one in my rules list. Okay, so here they are talking about, okay, Rust up, toolchain install. Okay, ESP flash. This seems like a lot of older stuff. Because a bunch of these things are, well, okay, these things do need to be installed. Um, Other than this, you also need ESP up, and I'm kind of glad that we went the ESP up route, because the ESP in ESP up, it also, like, it installs. So the reason we had to use ESP up was because we weren't targeting RISC-V. We were targeting Extensa, because that's the CPU that my ESP32 has. And so for that, it was suggested that we download and install ESP up, and through ESP up we install the entire like tool chain that's required. As an added bonus, ESP up also installed the targets for RISC-V. I don't remember if there was more than one, but yeah, it installed RISC-V related targets as well, not just extensor targets. So it kind of solved both of those problems. And I think this is also the way that they are recommending for us to do. Workshop repo. Okay, we are here and then we are here. Hello world. Okay, markdown sources for this book. All right. So this is the Hello World application. The Hello World application is basically a project generated with ESP generate. Let me show it to you guys here. Um, I think it is in intro. Yeah, I believe this is the one. Let me just confirm. Okay, this says source. Yeah, yeah, this is the one. Give me a second here. Okay, hello world. I think this is, yeah, yeah, this is what we are looking for. So in here, so this is the hello world. I cloned this entire repo so I can like look through some of the examples. Um, Wait, here there's only a main.rs. Where's does it not, hold on. Let me check. Actually, did Ubuntu open up properly? Yeah, no, it's not gonna open up. I have to I have to look at this on another machine. Give me a second. Okay, let's open up Yahtzee. Here we have the source, which just has main.rs. You know what? Okay, wait. So the project that I generated using ESP generate, that project has a library and a main thing. So I'm trying to find an example of something that has, that. Another interesting thing here is um, you have this project. I just remembered that, um, hold on, where is it? So we have intro. Oh, this is Hello World. Let's go to something else and see. Let's take a look at Blinky. So in Blinky, there's an examples thing, um, which is this. And then there's also this main.rs. I'm not able to show the library one. I guess once I'm able to log into my Ubuntu machine, or whenever I'm able to show the Ubuntu machine on stream, then I'll be able to show you that what ESP generate is generating, the project that is generating, it has a library and a binary component. I so I'm kind of confused as to how I'm supposed to be using that. But I'm sure we'll come across something like that here as well. Um, okay. Yeah, so this is interesting. Um, how do I find out if something is a library or a binary? Because from what I've seen within like library crates, to test out the library itself, you'll have a separate binary crate, which is sometimes or often a child of that library crate. But yeah, I need to do some research on that. Let's read up on this. Generating projects from templates. So this is, let's see what this says. Because at this point, I feel like there's older information and newer information. Because I'm pretty sure, and this is another issue. This is also why I think there's older information and newer information, because there's a bunch of stuff that's leading to, um, there's a bunch of dead links basically. I could directly go into ESP generate. There doesn't seem to be official documentation for this, at least from what I've seen. There's like information here, but that's about it. Um, let's see. Maybe somebody asked the question here about changes to ESP generate, or maybe there's something under discussions. Okay, let's get rid of this filter completely. How do I complete the TUI? This is from July. Okay, the bottom row is supposed to tell you this, but S, yeah, okay. I've done that. Okay. This is not what I'm looking for. ESP generate is slow. Toolchain name not updated. Okay, let's take a look at the closed ones. Okay, okay. Features to select toolchain, and okay, I believe this got added recently. I don't fully understand what exactly this is doing, because it says okay, feature to select toolchain. There's one option in the TUI to select the ESP toolchain, and my assumption was that that would be used out of the box. Like that was my assumption that that would be the default selection, because using the ESP toolchain, it's going to then use a specific compiler and um, specific targets and whatever other like very ESP32 specific things it needs to use. It's not going to use the regular thing that's targeting the PC, and it's not going to use a regular stable Rust. However, when I did select that, I didn't see too much of a difference. So that kind of confused me. Now, when I say difference, I mean I looked at the 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 config file in the .cargo directory, and I also looked at cargo.toml. In both of these, I didn't see any difference between them. So then I was kind of confused as to what exactly is going on. But then again, ESP up, or the ESP toolchain, is responsible for the compilation later on, right? So I would expect some traces of it to be mentioned somewhere, but it wasn't mentioned. So I was kind of confused. Even when I selected that, is this for that, or is it for something else? Let me see. Hold on. Okay, I've added the custom toolchain name in the PR. This issue tracks adding a prompt to the TUI version to let users choose existing toolchain. All right, let's take a look at that. ESP up allows you to choose custom name for the toolchain other than ESP. It'll be nice for ESP generate to allow us to also for it will be nice ESP generate also allow to specify custom toolchain name. Oh, okay. This is not for adding the ESP toolchain. It's for adding your own custom toolchain, which makes sense. If people have their own custom workflows and their custom tools that they want to use instead of what's provided over here, what's provided out of the box, then they should be able to do that. Okay. Um, yeah, I might just be confused about what exactly selecting the tool chain entails in this case, because I would assume that it would also dictate which compiler gets used, and there's a bunch of other custom things that have to be used. Man, I'm holy shit, voice crack. Man, I'm yawning like crazy. To be fair, I did only sleep for like, I don't know, 4.5 hours, and then I woke up and then I did a bit of cleaning in my room. Well, less cleaning and more. There's one specific area in the room where I have this big cardboard box, and in that cardboard box, I have a bunch of electronics that I kept. Um, some not working, some working. And the main reason I kept them is so that at some point in the future I can take them apart and like pull parts out of them. Various things like, ports and pins and any components or ICs or maybe even what do you call them, screens of some sort, or a keypad of some sort, stuff like that. And because of that, I kind of over time I gathered a whole lot of essentially garbage. um, I did it on purpose because I did see some utility for it, but the problem is that I don't exactly know when that utility is going to be required. So like it's one of those situations where it's like, okay, I might use this at some point in the future, and I kind of am interested in studying the circuitry of this thing. So, you know what? I'm going to keep this aside for now. I'm not going to throw it. I'm going to keep it in this box. And similar to that, I have multiple other things. At some point in the future, I'm going to find another thing that maybe uh, my my mom or dad or my brother or anyone, they're about to throw it away, and they'd be like, okay, hey, do you want this? Maybe you might want to take it apart or something. And then I'd be like, yeah, sure. I can hold on to it. And just like that, I had a bunch of uh, pretty much clutter that was taking up space in my room. So today, in one of those boxes, I started clearing out some of the stuff. I haven't cleared out all of it, but I'm happy with the progress that I made today. In like two or three more sessions, I'll get a couple more things out. Today, I got a fax machine out of it, a very old fax machine. And instead of just throwing it, for some reason, I got really curious about the circuitry inside it. And I was like, okay, let me open this thing up. I spent some time opening it up and taking it apart and taking out the circuitry from it. And I did eventually end up deciding that, yeah, I'm probably not going to be using any of this stuff. So I'm just going to throw it. Um, however, give me a second. Okay, yeah. Sorry, got distracted with something. Where was I don't even remember what I was talking about. Something about the fax machine. I took that apart. Oh yeah, I did eventually decide that I'm not going to be using it, so I did end up throwing all of the stuff that I'd taken apart. But it was a good experience. I did get to explore the circuitry, and after exploring it, I determined that okay, I'm not going to be using any of this. Though I could have, I actually could have. It was really interesting looking at the different components that it was made up of. It's worth noting that that fax machine was from like the early 2000s. So the circuitry in that, the tech in that was pretty primitive, but it was good for that time. Hold on. Yeah, okay. Yeah. So, um, anyways, it was interesting taking that thing apart, and then I had a couple of older power supplies. At this point, I have like a couple of different power supplies lying around, so I have to like put labels on the ones that do work and the ones that don't work. And I had two that I was kind of confused about whether they do work or don't work. but I didn't want to take a chance. I think those two were. It was a situation where I wasn't. I didn't have utility for it at the time because I did have power supplies that kind of failed because like over time, sometimes power supplies will give up or burn out or whatever. They due to wear and tear and due to their age, sometimes they'll just die. And I didn't want to throw away the power supply because one of them, I took the fan out of it, and I believe I actually did use the fan in another situation where I needed it. And speaking of fans, in one of the other power supplies where I was gonna that in one of the other power supplies that I didn't have much use for, there was a big fan in there. So I opened it up, and something that I noticed before even opening it up was I looked at the case and I was like, dude, and these are like the cheap power supplies. These are not expensive at all. They're like $10, $15 power supplies. Actually, $15 to $20 power supplies. They're not expensive at all. They're cheap. Sorry, got distracted. Okay, I was talking about power supplies and how cheap they are, and but yeah, I mean they're cheap, but they get the job done. They're great. They're not great for situations where you need a much higher continuous output, but they're great for very basic use case. So like if you have a computer that's not very high end, these power supplies are not meant for high end use because with high end computers, you have a higher amount of power, a higher amount of continuous power that is used. There's a difference between the peak power that the power supply can give and the continuous power that it can give. Peak is fine. It can be rated high, but that's not continuous. Continuous means it's able to continuously give that high amount of power. And usually with the cheaper power supplies, the reason they're cheaper is because they don't give out a high amount of power continuously. They can have a high peak, but they're not meant for situations where you do need a high amount of continuous power. So like if you have well, this is an older example. I don't know how much it applies now because like tech has definitely changed now. But like back in the day, this is how we would look at it. You would be powering your DVD drive, your hard drive, your your CPU fan, your motherboard. All of these would be powered off of the power supply, right? And then additionally, you would have certain expansion cards, like the GPU is one very famous example. Um, Sorry, zoned out. But yeah, there are situations where expansion cards, like for example a GPU, but it could also be something like a sound card or um, I don't know what other expansion cards you have. Different types of expansion cards might need extra power. So, like the GPU is a great example. Some of the higher end GPUs, they okay. I don't know about now, but they used to have their own dedicated power slot. So you would connect the power supply, one of the terminals of the power supply, directly into the GPU. Now, when you have those kinds of situations, you definitely don't. Sorry, zoned out. Um, anyways, so I was looking at this power supply, right, and I realized that there have been situations where I needed a case for some project that I was working on, but I didn't have a case. Um, so why don't I hold on to this case? I can take out the circuitry from the inside, but I can hold on to the fans and the case itself. One of them had a pretty big fan in it, and I need to check if that fan works, because if it does, I can make a cooling pad out of that fan and that case. The complication I would have there is that these fans are powered by 12 volts, so I'm going to need another working power supply to power them. That's the only issue that I would have, but other than that, everything else is fine. I can find a way to um, power them using using the, well, not power them, control them, or control the powering of them using an ESP32. I'll have to look into how to set up the logic there. Um, the simplest method I can think of is using relays, or one relay. Um, but the relays that I have are for much higher voltages. I don't know if they work for like the lower voltage as well. Yeah. Okay. Okay. So, yeah, I spent some time. Sorry, I'm a bit distracted. I spent some time taking apart a couple of a couple of the electronics that I had, and also getting rid of a couple of the things that I don't need. And yeah, I just remembered that I was talking about this because I'm also getting kind of sleepy. So I was wondering like why that was. So it's a combination of me having done that stuff and also not having slept very well. Well, any progress that I was going to make with doing ESP32 stuff, I kind of made most of it off stream. I didn't really do much on stream today, but like I wanted to. Okay, all right, dude. You know what? Okay, I made whatever progress I was gonna make. Um, I made it off stream. Um, I guess we'll do something tomorrow. I didn't want to miss a streaming day, so I did what I could. But unfortunately, yeah, I kind of messed up. The timing thing was also on me to a certain extent, but it is what it is. I'm gonna continue doing more research, and yeah, dude, I'm 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 gonna keep doing ESP32 stuff. I'll try and understand this whole project structure and how to set up the examples and stuff like that, because the examples are targeted towards RISC-V CPUs. So I need to find a more, let's say, easier or less hectic way um, to apply that to my situation, which is extensor. Worst case scenario, I'll just copy paste the code. I don't need to run the entire thing. But I don't think I need to do that either. I just need to change the target, because like this code is for older stuff. Like the newer, I feel like the newer ES. That's another thing. I need to look at the changes that have taken place in ESP generate, and like what exactly ESP generate is generating now, because none of these examples. Why was that so hard to say? None of these examples seem to have a library. Um, yeah, none of these examples seem to have a library. They all seem to be binary crates. But then when I'm using ESP generate right now, I'm getting a library, and inside that library crate, there's a binary crate. So I need to, you know what I could do? I could just, I'll have a conversation with Gemini about this, because maybe Gemini has an idea of like what was happening before, what's happening now, and what's this whole project structure and stuff like that. But yeah, okay. So that's gonna be it for today's stream. I don't think I'm gonna raid anyone today. I'm just gonna end the stream, and then I'm gonna get back to working on this. So yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time.